Imagine waking up to a sunrise that takes 4 hours to complete. You open your eyes in darkness, and by the time golden light floods your bedroom window, you've already had breakfast, gone for a run, and started your workday. The sun doesn't rush. It crawls across the sky with the patience of a glacier, painting the clouds in slow motion, stretching shadows like taffy across the ground. This isn't a dream. This isn't some distant alien planet. This is Earth, your Earth, but with one fundamental difference. Time itself moves at half speed. Every second lasts 2 seconds. Every heartbeat stretches. Every breath deepens. And in this world, everything you know about life, biology, civilization, and existence itself would be fundamentally, beautifully, terrifyingly different. Welcome to a world where time moves twice as slow. Let's begin with the most immediate, visceral change, the day itself. Right now, on our Earth, a single rotation takes 24 hours. 12 hours of daylight, 12 hours of night, give or take, depending on the season and your latitude. But cut that rotation speed in half, and suddenly you're living in a 48-hour day. The sun rises, yes, but it takes its sweet time climbing to its zenith. Morning lasts the length of an entire workday. Noon stretches on for hours. And when evening finally arrives, it doesn't rush toward darkness. It lingers, golden and amber, for what feels like an eternity. Then comes the night. Not a brief, 8-hour slumber, but a full day's worth of darkness. 24 hours under the stars. 24 hours of moonlight, if the moon decides to show up. Think about what that does to your body. We evolved under a 24-hour cycle. Our circadian rhythms, the internal biological clock that tells us when to sleep, when to wake, when to eat, are hardwired to that pattern. It's not cultural. It's not learned. It's genetic, written into nearly every cell in your body. But now, you're being asked to stay awake for 24 hours straight. Could you do it? Your body would fight you. After 16, maybe 18 hours, exhaustion would set in. Your cognition would falter. Your reaction times would slow. You'd start making mistakes. And yet, the sun is still up, still demanding your attention, still insisting it's daytime. Eventually, you'd have to sleep, even while the world is bathed in light. And when you woke up, maybe 12 hours later, the sun would still be there, hanging in the sky, mocking your confusion. Or maybe, just maybe, you'd adapt. Evolution is patient, after all. Over generations, over millennia, the human body would begin to reshape itself around this new reality. Sleep patterns would fracture. Instead of one long sleep, you might develop a biphasic or polyphasic rhythm, multiple sleeps throughout the day and night. You'd nap in the afternoon sun, sleep deeply in the middle of the night, wake for a midnight meal, and then sleep again before dawn. Your internal clock would stretch, bend, and eventually break free from the 24-hour tyranny it once obeyed. Children born into this world would never know the old rhythm. To them, a 48-hour day would feel as natural as breathing. But let's zoom out. Let's talk about the planet itself. A slower rotation doesn't just change your sleep schedule. It changes the weather. It changes the winds. It changes the oceans. On our Earth, the rotation creates the Coriolis effect, the force that causes hurricanes to spin, that drives the jet stream, that shapes global wind patterns. The faster the planet spins, the stronger the effect. But slow it down, and everything gets weird. The jet streams weaken. Weather systems stall. Instead of storms racing across continents in a matter of days, they linger, parked over cities and farmlands, dumping rain for weeks or battering coastlines with relentless wind. Droughts last longer. Heat waves become existential. The whole climate system loses its dynamism, its ability to quickly redistribute heat and moisture around the globe. And then there's the temperature. A slower rotation means longer exposure to sunlight on the day side and longer periods of darkness on the night side. The day side bakes, the night side freezes. In our world, the relatively quick rotation keeps temperatures moderated. Heat doesn't have time to build up too much during the day, and cold doesn't penetrate too deep at night. But stretch those periods out, and you get extremes. Deserts become furnaces. Polar regions experience months of continuous darkness. Well, not months, but you get the idea. Followed by months of continuous light. The equator might remain habitable, temperate, balanced. But the further you go toward the poles, the more hostile the environment becomes. Ocean currents would shift. Right now, the rotation of the Earth drives major currents like the Gulf Stream, which carries warm water from the tropics to the North Atlantic, keeping Europe far warmer than it would otherwise be. Slow the rotation, and those currents weaken or disappear entirely. Coastal climates that once thrived on the moderating influence of the ocean would find themselves at the mercy of continental extremes. Marine ecosystems would collapse and rebuild in new configurations. Fish migrations would change. Coral reefs might die off in some regions and flourish in others. The ocean, which covers 70% of the planet's surface, would become a fundamentally different place. And what about life? Not just human life, but all life. Every organism on Earth evolved under the tyranny of the 24-hour day. Plants open their leaves in the morning and close them at night. Animals hunt, forage, and mate according to the rhythms of daylight and darkness. Insects emerge at dusk. Birds sing at dawn. The entire biosphere is a symphony conducted by the rotation of the planet. Change the tempo, and the symphony falls apart. Or does it? Evolution is remarkably good at finding solutions to problems. Given enough time, and we're talking thousands, maybe millions of years, life would adapt. Plants might develop thicker leaves to survive the longer, harsher days. Animals might evolve new sleep patterns, new hunting strategies, new ways of regulating body temperature. Deserts might give rise to creatures that burrow deep underground during the day and only emerge at night. Forests might become dominated by species that can photosynthesize for extended periods, storing energy like biological batteries. But here's where it gets truly strange. Let's talk about aging. Because in a world where time moves twice as slow, the concept of a year changes. Right now, a year is defined by Earth's orbit around the Sun, 365 days, give or take. That doesn't change just because the planet rotates slower. The orbit stays the same. But the number of days in a year does change. If each day is now 48 hours instead of 24, then a year contains only half as many days. Instead of 365 days, you'd have about 182 and a half days in a year. Seasons would still happen. Spring, summer, fall, winter. But each season would last fewer days. Winter wouldn't drag on for months. It would be over in what feels like a few weeks of daylight cycles. Time itself would feel compressed in some ways, stretched in others. And here's the kicker. If we're measuring human lifespan in days instead of years, you'd live longer. Not biologically, Your cells would still divide at the same rate. Your telomeres would still shorten. Your organs would still age. But in terms of experienced time, you'd have more of it. Let's say the average human lifespan is 75 years. On our Earth, that's about 27,000 days. But on slow rotation Earth, where each day is 48 hours, those same 27,000 days would span 150 years. You'd celebrate your 100th birthday while your body was only biologically 50. Your children would stay children for twice as long. Your career would span decades that feel like centuries. You'd have time, so much time, to learn, to grow, to explore, to make mistakes and correct them, to build and rebuild your life over and over again. But would you even want that? There's a psychological weight to time. We measure our lives in milestones: birthdays, anniversaries, graduations, retirements. We structure our identities around the passage of years. But if years are suddenly twice as long, does that change how we perceive progress? Does it make us more patient, more thoughtful, more willing to play the long game? Or does it make us complacent, lazy, trapped in the agonizing slowness of a day that never seems to end? Imagine being a child in this world, waiting for your birthday. It doesn't come once a year. It comes once every 182 days. Christmas, or whatever holiday you celebrate, arrives twice as fast in terms of day-night cycles, but each individual day leading up to it is twice as long. Time becomes elastic, subjective, almost meaningless. And let's not ignore the social implications. Civilization, as we know it, is built on the framework of the 24-hour day. We work 8 hours, sleep 8 hours, and have 8 hours for everything else. That's the industrial model, the capitalist model, the modern model. But throw that out the window. In a 48-hour day, what does a work schedule even look like? Do you work for 16 hours and sleep for 16? Do you split the day into multiple shifts? Do you abandon the concept of a workday entirely and just live? Some people might thrive in this world. Artists, writers, scientists, people who need long, uninterrupted stretches of time to think deeply, to create, to experiment. But others might struggle. The 9-to-5 office worker would become an anachronism. Factories would have to completely rethink their shift rotations. Schools would face a nightmare trying to keep children engaged for extended periods. And let's be honest, if you think kids have trouble paying attention in a 1-hour class, imagine trying to hold their focus in a world where morning lasts 12 hours. Transportation would change. Right now, we schedule flights, trains, and buses around the assumption that people want to travel during daylight and sleep at night. But in a world where daylight lasts a full day, you could take a transatlantic flight and never leave the sunlight. You'd board in New York at noon, fly for 8 hours, and land in London while the sun is still climbing toward its peak. Jet lag would become even more disorienting. Your body would have no idea what time it is because time itself would feel meaningless. Airports would operate continuously, 24 hours of daylight followed by 24 hours of darkness. Passengers stumbling through terminals in a daze, unsure whether they should be eating breakfast or dinner. And then there's culture, art, music, literature. So much of human creativity is tied to the rhythm of day and night. We write songs about sunrises and sunsets. We paint the golden hour. We tell stories about the magic of twilight, the fear of darkness, the hope of dawn. But in a world where dawn takes 4 hours and dusk lasts half a day, Those moments lose their urgency. They stop being fleeting and become ordinary. Maybe that's not a bad thing. Maybe it gives artists more time to appreciate the subtleties, the gradual shifts in light and shadow, the slow dance of the sun across the sky. Or maybe it robs them of the inspiration that comes from impermanence, from the knowledge that beauty is brief and must be captured before it disappears. Philosophically, this world challenges our relationship with time itself. We often say, we don't have enough time, not enough time to finish our work, to spend with loved ones, to pursue our passions. But is that really true? Or do we just fill the time we have with noise, with distractions, with busyness for the sake of busyness? In a world where each day is twice as long, would we finally have enough time? Or would we just find new ways to waste it? The ancient Greeks had two words for time: chronos and kairos. Chronos is the ticking of the clock, the relentless march of seconds and minutes. Kairos is the right time, the opportune moment, the quality of time rather than the quantity. Maybe in a slower world, we'd learn to live more in kairos and less in chronos. Maybe we'd stop rushing and start savoring. Or maybe we'd just get bored. Let's bring it back to biology one more time, because this is where things get truly speculative. If evolution had millions of years to work with, what would humans look like in this slower world? Our eyes might adapt to handle the longer periods of bright sunlight, maybe developing natural polarization or enhanced UV protection. Our skin might thicken, or our melanin production might ramp up across all populations to protect against extended sun exposure. Our metabolism might slow down to conserve energy during the long nights. We might evolve better fat storage, like bears preparing for hibernation, or develop the ability to enter torpor, a state of reduced metabolic activity during the coldest, darkest hours. Some scientists speculate that slower environmental rhythms could even affect brain development, giving rise to longer childhoods, extended periods of neuroplasticity, and maybe, just maybe, greater cognitive capacity. But here's the uncomfortable truth. Evolution doesn't care about comfort. It doesn't care about happiness. It cares about survival and reproduction. And in a world with extreme temperature swings, weakened atmospheric circulation, and unpredictable weather, survival would be hard. Very hard. Coastal regions might become uninhabitable due to temperature extremes. Inland areas might turn into deserts. The habitable zone might shrink to a narrow band around the equator, forcing humanity into a smaller, more concentrated space. Conflict over resources, water, food, land, would intensify. Societies would fracture. Civilizations would rise and fall. And through it all, the sun would continue its slow, inexorable crawl across the sky, indifferent to the struggles below. Yet there's something beautiful about this world too, something almost meditative. Imagine standing on a hillside, watching the sun rise, not rushing, not racing, but easing its way into the sky, degree by degree, minute by minute, hour by hour. You could sit there all morning and watch the entire spectacle unfold. You could see the exact moment when the first ray of light touches the horizon. Watch the colors shift from deep indigo to violet to pink to orange to gold. You could witness the birth of the day in real time, with a patience and presence that our fast-spinning world never allows. And then, at the end of the day, you could do it all over again with the sunset. 4 hours of slow, glorious, painterly light, the sky transforming itself, brush stroke by brush stroke, until the stars finally emerge. Maybe that's the gift of this slower world. Not more time exactly, but better time. Time that forces you to slow down, to notice, to be present. Time that can't be rushed or optimized or hacked. Time that simply is. In our world, we're obsessed with speed. Faster internet, faster shipping, faster results. We've convinced ourselves that efficiency equals happiness, that productivity equals worth. But what if we're wrong? What if the things that matter most, connection, creativity, contemplation, require slowness? What if the key to a meaningful life isn't doing more, but being more? Of course, this is all speculation, a thought experiment. Earth isn't going to suddenly start rotating twice as slow. The laws of physics that govern planetary motion are ironclad, unchanging. Our 24-hour day is here to stay, at least for the next few billion years, until the sun expands and swallows us whole. But that doesn't make the question any less valuable, because when we imagine these alternate worlds, we're not just exploring physics or biology or climate science. We're exploring ourselves. We're asking what it means to be human in a universe that's constantly changing, constantly challenging us to adapt. We're testing the limits of our resilience, our creativity, our capacity to find meaning in chaos. So here's the final thought. The next time you watch a sunrise, or feel the heat of the afternoon sun, or marvel at the stars on a clear night, remember this. You're living in a world perfectly calibrated for life as you know it. The 24-hour day, the tilt of the axis, the distance from the sun, the composition of the atmosphere, it's all a miracle of cosmic timing. A slower world would be different, yes. Strange, yes. Difficult, almost certainly. But it would also be a world where time stretches out before you like an open road, where patience becomes a virtue, not by choice, but by necessity, where every moment has room to breathe. And maybe, just maybe, that's a world worth imagining. Because in the act of imagining, we learn to appreciate the world we have and the precious, fleeting, perfectly timed gift of each passing day.